Take this moment to record. Okay, so we're just going to be covering React component hooks, useState, stay props, and then children props, and built-in, and then built-in properties as well. So let's just get started with the component lifecycle. So one thing to understand about React components is it is like a living organism. It is born, it evolves, and eventually it will cease to exist. So these are kind of like the three state. These are kind of those three stages can be translated to the mount stage. So the mount is where the component is born and added to the screen for the first time. Update is when something changes. Usually, when this changes involves the state or its props, and then React re-renders it. And then finally, there's the unmount stage where the component is removed from the screen. So a helpful way to connect with this is this two hooks is with the use effect method. So we can run code when the component mounts. We can also return a cleanup function that runs when it unmounts. So take a look at the coding example that we have here. The so as I mentioned before, use effect runs once when the component is mounted. Console log just runs on mount on the mount stage, and then in this case the return is the cleanup function. And then once we're in the return function, this console log statement is executed, and then the empty array that you see at the last line, it just means that the effect only runs once after the first render. So now that we have some idea about the component lifecycle, hooks will start to make a lot more sense because they let us respond to those moments inside function components. Now, the one big question is, so now that we hooks start to make a lot more sense because they let us respond to those moments inside function components. But let's talk about used state and why React state matters. So a good question that some of you may have thought about this is just why can't we use a regular JavaScript variable? So the problem with that is React is usually unaware of changes to normal variables. So if I go ahead and update a plain variable, JavaScript would know it has changed, but React does not. Since React was never told that anything has changed, it will not re-render the component, and thereby the UI stays the same. So that's what this broken counter example on the bottom left is showing. We have a local variable called count, and inside handle click, we increment it by 1. If we log it to the console, we can see the value changing in memory, but the text on the screen does not update because changing a regular variable does not trigger React's update cycle. So in React, if you want the screen to update, we need states. So state changes basically tell React that something has changed. Please re-render this component. So yeah, this regular variables can change, but React will not notice. State is special because React watches it and re-renders the UI when it changes. And that is why we need now let's try to do a quick introduction to hooks. So hooks are special functions that let you hook onto React features from your functional components. They let us use state, lifecycle, and other components, magical other React features without writing a class component. But there are two rules to remember whenever you're using hooks in React. The first, you should always only call hooks at the top level. So that means we should not call them inside loops, conditions, or nested conditions. The reason behind that is that React expects hooks to be called in the same order every time a component renders. And another reason why you should, and another rule is that only hooks can be called from React functions or from your own custom hooks. So, in other words, hooks belong inside React related functions, not inside regular JavaScript functions. So, the takeaway from this is keep hooks at the top level and only use them inside React function components or custom hooks. And let's take a look at useState, which is sort of like React's core hook for memory. It lets a component store a value and update that over time. So when we call useState, React gives us back a pair, a pair of values. So the one would be the current state value and a setter function that we can use to update it. So you will usually see that with array in a sort of like an array structure, like quantity and set quantity. This is just one particular example that you can see on the right side of your screen. And the first item, where the first item is the current value, and the second item, set quantity, is the function we use to change that value. And the value inside use state 1 is the initial state. So this component starts with a quantity of 1. The important rule is that we should always use the setter function to update the state. If we try to directly change the variable ourselves, then React will not re-render correctly. So the so in this example, we're just trying to increase or decrease the quantity. So this is what it's doing. It's just one small function, and it's kind of so useState would give React a way to remember values between renders, and the setter function is how we tell React to update the UI. Are there any questions so far about what has been discussed in the presentation? I just wanted to take a moment to pause and see where everybody like if there are any questions so far. Okay, so I'll just keep going, and we'll always have time for questions at the end as well. But even if you do come across a question, feel free to post it in chat, and I will be sure to take a look whenever I can. So the next concept to really understand is stale state. So stale state happens when an update depends upon an older value instead of the most recent one. This usually comes up when React patches update together. So, for example, if we try to set like set count, if we try to increase the counter by saying set count plus one twice, we might expect the count to go out by two. But both updates may use the same old value of count, so the result ends up increasing by one. It's kind of like flipping a light switch fast. The light only ends up in a final position, which would end up with missing the intermediate toggle. So the safer pattern here would be the functional update, where we could set the current we can set the current count would be like count plus one. So that would tell React to use the latest available state from each update. And then you should, and then, but both updates would use the same value of count. So the result only goes up by one instead of two. So that's why the safer pattern right here would be using a functional update, where we pass a function into the setter instead of a value. React will give that function the latest and guaranteed state value which is like freshly updated. So the rule of thumb here would be this: anytime your next state depends upon the previous state, use the functional updater. Use functional updates. This is especially important for counters, toggles, and list updates. And now let's take a quick look upon uh, we won't use effect and use ref. We won't be going into these too as deep as we can, but it's always a good idea to know what we are, because these are concepts for like later sessions. But I feel like it would be a good idea to know what it is. So use effect is used for side effects, which means that whatever work happens outside the normal render process. So common examples would include fetching data from an API, or setting up a subscription, or manually interacting with the DOM. DOM and use ref is used to hold a reference to a DOM element or store a mutable value that should persist across renders without causing a re-render. So some common examples would be like managing focus on an input field, storing an interval ID, and holding a changeable value or mutable value across renders. So a simple way to remember it is this. So use effect helps you do something after the component has been rendered, and use ref helps you keep a reference or mutable value without re-rendering. We will be sure to revisit these concepts in the later sessions. But for now, let's just continue with props and how those components receive data. Okay, so one more React idea before props is immutability. So in React, there's just we should never mutate state directly. Instead, we create a new array on an object and pass a new value into the setter. Why does that matter? Because React often checks whether state has changed or not by comparing references in memory. So if we modify the existing array or object directly, the reference still stays the same. So React may not detect a change, and the UI may not get re-rendered. So that's exactly what the example on the right is showing. So if we're trying to add new add items to a card, so we could use the push method here, but it mutates the original array. But the setter would pass back the same array reference. So React may not see anything true. So the correct way to work through that is that we use the spread operator to create a brand new array. So in this case, we will just be creating a variable called new items. And now that the reference is different, so when we call the setter method, React can detect the update and re-render. So that is why it is always important to make sure that you don't directly change this state in place. Always create a new array or an object whenever you end up updating the state. Now, let's take a moment to talk about props. Props, or short for properties, are the way that data gets passed from a parent component down to a child component. A helpful way to think about props is that they work a lot like arguments in a JavaScript function. If a parent component wants a child component to display some information, it can pass that information to props. Now, there are two key ideas here. So the way to so first, React uses one-way data flow. That means that data will always move from parent to child and not the other way around. And second, props are only read only. So a child can a component can use the props it receives, but it should never try to modify them directly. So if a parent passes so for example, if a parent passes a name prop into a child, the child can display that name, but it should not try to change it. Now, let's look at this small example here to show that how a parent sends props and how a child receives them. So, so in this example, the parent component is the product list, and the job is to hold the data and the rendering logic. Inside product list, we map over an array of products. For each product in that array, we will be sure to render only one product card, and then and the product card, that product card is the child component, and then each child receives its own data through the props like name, price, and image URL. So this is one example of how the one-way data flow that I had explained in the earlier slide. The parent owns the data, and the child just receives that data and displays that particular data. So the key prop is really special here. It helps identify React which items have changed, were added, or were removed when rendering list. So now that we have seen regular props, let's try to understand the children prop. So the children prop is kind of like a special prop used for nested content. The children prop helps us pass JSX or components between a component's opening and a closing tags as well. So this is really useful for wrapper components because the wrapper can provide layout or styling where the content inside can be different each time. So for this, so in this example on the bottom, the promoted item is the wrapper component, and the card is being passed inside it as children. So that means promoted item can add its own UI like the hot item badge and then render whatever child content was placed inside. So this is one of the main ideas behind compositions in React. The wrapper does not need to know exactly what is inside ahead of time, and this is also one of the principles of object-oriented programming, which is also known as abstraction. And then finally, let's take a look at some built-in props. So there are some built-in props in React. React uses many HTML attributes, which would be familiar, but a few of them are written slightly differently in JSX. So for example, class name would replaces class when you want to add CSS classes. Style takes a JavaScript object, and the property names are written in camel case. It's, almost like how you would write property names in typical CSS files as well. No. So for CSS files, you probably use lower cases and separated with hyphens. But camel casing could be another way to go. And the HTML4 replaces the normal for attribute on label elements. And then we also have some event props. They let us respond to user actions. So for example, on click runs when something is clicked, on change runs when the form value changes, and on submit runs when the form is submitted. One important detail is that event prompts take a function as a value, not the result of calling a function. Uh, I hope everything has been clear. One important detail is that, yeah. So, for example, if we were to implement an on-click handler, so we would pass the function that would handle the on-click event, and not just the uh, entirely the function declaration. I don't know if that makes sense, and I'll be sure to show it as we go on with the coding examples that I have prepared for this. And so the big takeaway here is that JSX looks very similar to HTML, but some attributes would be renamed, and inline styles are written as JavaScript objects, and event handling is done by passing functions to event props. So I think with that, here are here are some key takeaways about what this. Just to quickly recap, we have covered state, which is what a component's memory managed with useState. Props describe which describe how data flows from parent to child, and then its life cycle, which includes the mount, update, and unmount phases. And then there are hooks, which include special functions like useState and useEffect that let you use React features. And then finally, there's immutability, which means we should never change states or props like directly. And for the next time, we will try to build on this by handling user events, controlled components, and forms as well. So, thank you. So, I'll just take a moment to answer any questions that you have about this particular presentation.
I would
Uh,
just like to make one recommendation, Karnik. It was great presentation, but it's so many concepts in one class. I think I mean I feel I mean, I kind of was a little bit confused and not very clear, but I think it's good. I wish these concepts were introduced one class at a time so that it would have been really reinforced properly. But it's okay. I mean, it's too much. Maybe we have a time constraint as well, right? So.
Well, first of all, I would just like to say that's really helpful feedback, and I agree with you that this was a lot of concepts in one session, and I appreciate you for pointing that out. So the goal of today's session was just to give a broad introduction so that the terms feel familiar. But I completely understand that learning these one at a time would make them easier to absorb and reinforce. But at the same time, we you also have to understand that you also have to understand that this is kind of how you also want to be mindful at the same time, and we make sure that everyone leaves here with a basic roadmap of the main ideas. So, and that is exactly why I record these sessions as well. So you don't really have to understand everything at once. This You can always go back to these recordings and try to make sure that you're able to understand these concepts as much as you can. And I believe that those concepts you will be able to understand these concepts once you try to practice those with some examples, or maybe with the assignments and the exercises as well. And yeah, so I hope that made sense.
Yes, that does. So, if I may ask, we will be going more in depth in our future sessions, right, on each of these? Just want to, yeah, just wanted to clarify.
So as for the future sessions, we would be going we would be trying to go in depth, but we would not go into as much depth as you think it is. We will just be covering every single concept that you need to know while for in order to build out like really good applications in React. And yes, as you and you will see that these concepts build on each other. So what helps most is that each upcoming class builds on the previous one. So today was just more about getting familiar with the vocabulary and the big picture, but future sessions will give you more chance to apply those ideas in context. So maybe in like the next few sessions, we will continue with hooks, events, and handlers. So, and then later on, as we move on to like more advanced topics like data fetching and hooks. So, the current expectations we have with you is that you're not expected really to like understand everything just in a 1 hour session. So the goal is just to build that understanding, and gradually as you practice more, you will find that that understanding is reinforced. I hope that makes sense.
That does. Thank you so much for clarifying.
Okay, so let's see.
Yes. Hi, I'm so sorry to interrupt you. I just had a quick question, and yes, and thank you for. I understand that it's like a broad. You're just like simply introducing all these concepts to us, which is really great. I so we just have like a vague, at least, idea of what we will be working with. But yes, I had a quick question. What when you say immutability, I just wanted to ask, like, what do you mean that you can't change directly? Like, yeah, I just
Yeah.
wanted to ask, what does that mean?
Okay. So that is exactly the next question that I was about to address. Jessica, thank you for bringing that from my attention. So immutability, when I say immutability, that means that instead of changing an existing array or object directly, we can create a new one with the updated value. So, for example, instead of just changing the original array with a method, with some methods, let's say push or maybe pop, we can make a new array using something like the spread operator. So that matters in React because React often detects changes by comparing references. So if the reference stays the same, React may not be able to realize that anything has changed. So even if you even if you change something in the object, the UI may not update the wave that we expect. So that is what I mean by immutability. So that is why it's always a good practice to not modify state directly. Instead, create a new version of it and then pass that new version onto the setter method. Does that make sense?
Yes, thank you. Thank you for clarifying. Thank you.
Karnik,
Okay.
just a follow-up question with that immutability. So is this only applies to references, object references, and not with like if it was just like a simple data type like an integer or is or no?
Um, okay. Let me see if that's actually a good question. Well, it matters most for reference types like arrays and objects because those can be mutated in place. But when it comes to primitive data types like numbers, strings, or booleans, you are not really mutating the old value here. You would essentially be replacing a new value. So let's say, for example, you want to there's a count a variable called count, which is one, and then if we just use the setter method to set it to two, that is fine. We are not modifying the number one. We're just telling React itself to store a new value. So the immutability issue comes up more with arrays and objects because methods like push or pop or directly changing other properties can modify the existing value in place, but the reference still stays the same. So I would say that this applies not just for arrays and objects, but for other primitive data types as well. So I hope that answers your question.
Yes. So what I'm understanding is we are yeah. So if we change a simple data type like integer and all, it still it won't take effect, right? Even if we change, we have to do it through the properties, right? The setters, right? Is that right?
Yes, that's exactly. That part is true for all React state, including simple values like numbers. So even with something like an integer, if you just change a local variable directly, then React will not re-render that. So you still need to use setter functions if you expect the user interface to update.
Got it. Thank you.
Okay, so let me just take a few moments and see if there are any other questions before we move on to the coding example we have for today's session.
Can I ask the question, sir?
Um, sure,
Uh,
sure.
that's a quick question. So in one of your slides that is called immutability and state,
Mhm.
there was on the right, there was the right weight immutability. And when the array was declared, it was like const new items equals, and there were three dots there. Three dots, cart
Okay.
items. What are those three dots? Can you explain, please?
Yes. So those three dots that you saw in the example is actually called the spread operator. So in that particular example, when I saw when it was like when one of the lines was like const new items is equal to like square brackets and then three dots, it means that you take all the existing items from cart items, copy them into a brand new array, and then add the item that you wish to add to the cart at the end. So let's say if the cart items was like let's say if your current cart had like apples and bananas, then the new items, and if you wish to add an orange into it, so the new items would have the original array, and it would create a new array that would eventually become like apple, banana, and orange. So the important part to understand that it does not change the original cart items array. It creates a new one, and that is why it works well with React state. So the spread operator is a very common way to copy arrays or objects without mutating the original value.
Thank you very much for explanation.
Okay. Let's take okay, so if there are no more questions, I would just like to take this moment to show the code let's just transition into the coding examples. So I just as we go through them, I will try to explain each example by line and then just try to connect back to the concept that it demonstrates so that it feels a little more concrete than the slides. Okay, I hope that I hope that every one of you is able to see the screen. Can you see the screen? I would just like some. acknowledgement, maybe just thumbs up or something. Okay. So now that we're in just the coding examples, I'll just go through one section at a time. Here is our so as always, all our React applications start with JSX, and then I've created like example components at the top, like counter, shopping list, student card, and student list. And then inside the app component, I did create like an array of students. Uh, and yeah, so in an array of students, this is just like some sample data that and each student object has about like an ID, name, and grade. And below that, I'm just returning like below that, and I'm just rendering each example section one by one. So counter is for use state, and then for to demonstrate what does use state and state includes, and shopping list is to just demonstrate the immutability, and the student components are for and the student components down here are for the props and children concepts that we've seen in this particular in the presentation. So let's start with the counter example first. So this is exact at the very top. We always use the use state. It brings in the hook that we always need to render the state, and then inside we use the at line 5 we use the count method to just create a state variable called count, and its initial value is 0. So and then I have two functions. So the function that says add to broken is intentionally set to be wrong. So inside it, we call this set count method twice. So at first glance, it looks like it should work, right? It should ideally it should be increasing the count, but both calls are using the same old value of count. So React ends up only increasing it by one. Let's take a look at let's take a look at it. You see that is how you see that is one way where this broken method doesn't work. And then as for what should be done is that it this the add to fixed methods shows the correct approach. So instead of passing the values directly, we pass the function that is like set count, and then previous is equal to previous dot one, that tells React to use the latest available state for each update. So when we do that, the count correctly increases by 2. If I try to set this counter by 2, you can see that the counter increased by the value of 3. So this particular example helps show the stale state problem, and the rule that whenever your next state depends upon the previous state, just use the functional updates as it has been shown in the add to fixed function. And then this is just the HTML that will help understand that just shows the entire component here. So let's try to take a look at the shopping list.
Karnik, can I ask you something regarding that count thing that you showed? So how is it getting the previous value over here? Like in the code, I mean, I'm a little confused. Inside the code, are you passing previous value somewhere? How does it know which is the previous value?
That's actually a great question. So, in terms of passing the value, we're not passing the previous value by ourselves. So, what is happening here in the fixed method is that when we use the functional form of the setter, like you can see right here, React automatically provides the most recent state value as an argument to that function. So the name can be anything. Previous is just a parameter name that we choose. You could call it pref, you could call it current count, or you could even call it anything else that would make sense to you. So we are not supplying that value anywhere. React is doing that. So you can think of it like this. So we give React a function, and then React calls that function for us. And then once the function has been called, React passes along with that call, they pass in the latest state value, and then we return the next value that we want. So in this particular line, previous is just the latest count value from React. Like I said, the name can be anything. I've just kept it previous so that it makes sense for me. And then the previous plus one is the new value that we want. And because React does that separately for each update, the second call sees the updated value from the first call. So, in short, we are not passing previous in ourselves. That is something that React does into the updater function automatically. Does that make sense?
Yes, thank you. Yeah.
Okay. Let's move on to the shopping list, which will help you understand a bit more
Um,
about I'm sorry.
Sorry, I just had a quick question. Can I just see the rest of the code? So when you're clicking the button and it says previous and then you're changing it from one previous to the next state. Yeah, can I just see in the code like what's
Sure.
getting passed? So what's getting passed into previous plus one is the count, correct? And that's being passed inside in the return section on the bottom. Can I
Um.
see?
Oh, okay. So you want to
Oh,
okay. So
sorry, I'm not.
yeah. So
I,
oh no. Oh no. That's totally understandable. Let me see if I could like try to add a console log statement here. I'm not sure if that will help, but we can always try. No, this is not like I said, this is not a new variable that will be created. But if you wanted to see what kind of values are being created, uh, so it's not really from the return at the bottom. It's coming explicitly from React inside this updater function. In this returning function, this is just the HTML components along with some CSS that help us understand. That just helps us build the entire visual block as to what you see right here on the screen. So from the return function, we're not really sending any previous values. That is being explicitly sent from React. So let me just try to paint a little picture here. So what in this first line, what would happen is that React will always take a look at uh, so let's say if the current count is zero, and then React would treat it like this. So in this first call, React would consider this as the current state, and then once it passes on previous was plus one, the count will be set to one. And then once the current count has been and then that thereby our current count is set by one. So for the second call, instead of looking at 0, it will look at 1 right here. And then since that is our current state, and then once that current state has been identified, it will just be incremented by 1. And that is how and that is how the counter increases from 1 to 2 when we try to add 2 to the current count. Does that
No,
make
yes,
sense?
yes. Yeah, that makes sense. I just want to see where exactly does the function gets called inside the return section. So the add to fixed, is it being called inside the button?
Yes, it is being
Okay.
called inside the button right here. So as soon as I click this button, the add to fixed will keep adding two more. And if I try to call the add to broken, that is where the add to broken method is being called. You can
So
see
when
it
it's
right here. Yeah,
okay.
so when?
Okay, so it's called right there. So you don't, when you call it, you don't actually add any parameters into it. So you
No, not
just put
really.
simply okay. Okay. I see.
Okay, so
Mm,
does that answer your question?
mm,
Okay,
yes, I mean
so
it's being yeah, so it's being called right there, but then you put fixed inside right here. So when it says add
yes.
to, and then you put inside the parameters fixed, that
Yeah,
fixed
so
that's inside.
so yeah, so right here the button labels are just completely different. This is just a part of the function names that I've clarified here are like add to fixed. And the only reason that I've added parentheses here is without these two parentheses, I would not be properly able to understand which button would be used to
Ah,
show that what version would work here. So that's the whole
I
reason that I've
see.
added parentheses in the buttons
Oh,
itself.
okay. It was just the label. Sorry.
Yeah,
I thought
yeah,
it,
it's
okay,
just
that's just the label. Okay. So you just literally just called the function without putting any what's the word? The parameters or arguments into the function?
yes,
Okay.
parameters, arguments, they're one and the same.
Okay. So because you don't add any parameters or arguments, it starts at 0, correct?
Yep. It starts
Okay.
at 0, and if you just use the add to fix, it adds 2. But if you try to use the broken method, even though it in the code it says that it should add 2, it only ends up adding 1 because we're trying to change the variable directly. And that is exactly why you can only see like 1 right here, the only 1 being added here. So I hope that makes sense.
No, that makes perfect sense. Thank you so much.
Okay. So let's move on to the shopping list. And uh, yeah, so where we can definitely see another example of actually mutating the state directly with an array. And then we the use state and everything. So the use state helps us set the initial array, and it also describes the state variable called items, and there is the second method. And then let's take a look at the wrong at the one way where adding butter directly would be the incorrect way of to update the list. And then one correct way would be to just use the spread operator, which is indicated by the 3. And then if I try to add butter right here, you can see that nothing changes. But then if I try to if I try to add butter correctly here, you can see that the butter has been added twice. Now, even though if I wanted, so the reason why this exactly happened is that even when I use the wrong function here, the code does push butter into my array. So React may not re-render because we pass back the same array reference. That's why it can feel like nothing happened, even though the array itself was technically changed. So after clicking add butter correct, we just used the spread operator to create a brand new array, and now React sees a new reference. So while the UI is re-rendered, that's why you can see the butter being that's why you may see multiple butter items appear. So the wrong button may have already mutated the array behind the scenes, but the UI did not refresh until the correct updates created a new array and it triggered a re-render. And in this code, you can see that there are buttons which just call the functions without passing any parameters. Just wanted to reiterate that these are labels. There's nothing being passed here. This is just one way to differentiate between the correct way and the incorrect way to add butter to your shopping list. I hope that makes sense. Uh, okay, so let's take a look at the student card components. This is nothing but a but this so this is where props become very visible. You can see that there is a function defined there where where would be passing like grade, name, grade, and highlight. It defines the component and immediately pulls value out of props. And then so this component will be expecting three props. First would be the name, the grade, and then whether it should be highlighted or not. So if and then a highlight equals to false means that even if that prop is not passed in, it will always default to props. And then this is just one particular structure. We could take a look at it later. But and then once we take a look at student list, this is kind of like the parent component, and then you can see that you should always make a point to import your child components, and then it just defines the parent component and pulls out two props. So the one prop would be the students, which is the array of student data, and then the children in this case are any nested JSX passed between the opening and closing student tags. And then this is then in the return method, it just starts the JSX for this component, which creates thereby an unordered list, which and then the children right here, it just nested renders any nested component content that is passed into student list. And then once the child components have been rendered, the student dot map just it loops to the student array which we had defined right here, and then for each student it would return one student card, and then the card would just render the child component. And then one important key to understand that key right here is an important line to add here because it gives React a unique key for each list item, and then we pass on the properties like name and grade. So this file just shows those both those ideas together, like regular props to students and nested content to children. And then so the key goes here on the map component, not inside the student card itself, because React needs the key at the point where the list is being created, and this is how the list is coming up. Now, if you are taken a closer look at the array, you will notice that there were only four. And where did this fifth student come from? So the answer to that question lies inside the Reactor, the app.jsx itself. I just wanted to take a moment to show what exactly it would look like if one of the student cards is highlighted, which gives us the component, the original student array, And then between the opening and closing student list tags, we are also manually pasting another student card. So that card is just not coming from the array. It is just being passed as children. And yes, these were the coding examples that I had for this session. Are there any questions whatsoever about any of the concepts that I've shown in the class or in the session?
I had some confusion with the children. Can we go and take a look at the code? One sec. I just wanted to understand
Sure.
something. Thank you.
Okay, so the children component, yeah.
Uh, yeah. So here you have children, right? Whatever is passed between student list tags appear here. So is this children is what is going to be the value of this children? Is oh this is where you are displaying, or no, sorry. Yeah.
No,
Uh
no, no, exactly. So anything, you were actually on the right track. So anything that is written between the opening and closing student list tags gets collected into the React into the children prop, and then it appears right here when we render the children. So in this app.jsx, if I write down a random student card, so this student card would come up would come up in this children property itself. So
okay.
students is a normal prop that is passed as data, while children is special because it represents the nested content that is placed between the student list tags that you can see right here in in these opening and closing tags. Does that make sense?
Yes. Uh, yes, it's kind of. So I was like,
Uh,
why are we not mapping children and students? If we map children, it will still render the same way, or that's not right, right? So,
Well, if the that's a really good question. So we kind of map over students because in this case, a student is an array of data, and we want to turn each item in that array into a student card, into a separate card for students. So, but one thing to understand is that children is different. So, in this particular example, children is already a fully formed React element, and that extra card that was placed between the tags would come inside that children component. So we do not need to map it because it is not an array of raw data that we need to transform. We can just directly render it with the children property. Does that make sense?
yeah. So the children is the actual React component that is getting formed with that student card. Is that right? Kind of.
Yes. So the manual student card that we created here, that is what will be rendered when we try to call upon the children component in the student list itself.
Got it. Yeah. Thanks.
Okay. Are there any other questions? Okay, let me just take this moment to pause the recording.